there's one more example here in this particular type, and we're going to have a look at this one here. We can see we've got to find the sum of this series, 1 squared plus 3 squared plus 4 squared plus 6 squared, etc., to 2n plus 1 terms. And once we've found that general expression, use it to find the sum to 49 terms. So let's have a look. We want to find the sum to 2n plus 1 terms. Now, what we need to do is have a look at what we can see is any particular pattern. It goes 1, 3, 4, 6, 7, 9. With just sort of looking, we can see that the 3, 6 and 9 are linked together, and the 1, 4 and 7. Okay, so there's two separate series there that we can look at. We've got 1 squared plus 4 squared plus 7 squared, and that continues on, and that is to n plus 1 terms, because that's our starting off series, because the very first term in that series is the 1, then that's going to have the extra term. Okay, and then plus 3 squared plus 6 squared plus 9 squared, and that continues on to n terms. So the same deal in this. We need to have our n plus 1 and n adding to the total in the question, which is 2n plus 1. Now, using sigma notation, from r equals 1 to n plus 1, our rule for that, we can see that the base for of the powers increases by 3 each time, so that's 3r, and we're not having to add anything when n equals 1 or r equals 1. It's just, oh yes we are, we have, because it's 3 1s are 3, we're going to have to subtract 2, so it's 3r minus 2 all squared. We're adding the next series, and that's just to n, so r equals 1 to n, and it's increasing by 3 each time as well, so that's 3r, and 3 1s are 3, 3 2s are 6, so we're not having to add or subtract anything from that, so that's just 3r all squared. What we'll do then is we'll expand these brackets. Okay, so expanding that, can see that that's what we get when we do. And with our first series, we can split that up into 3 more series with sigma notation, and so we're going to have 4 sets of sigma notation, which we can then utilise what we know on our information sheet and go from there. So we're going to have in our first one 9, r squared minus 12 sigma r plus r equals 1, so n plus 1 of 4 plus another 9. This is to n, not to n plus 1. R equals 1 r squared. So we can't combine those, even though the r squareds are the same. We can't combine those sigma notations because the end point is different. Okay, so then we'll go through and we'll get rid of the sigma symbols and replace them. So added a couple of extra lines here of working, just substituting the n plus 1 into the expressions for the sum for r squared for r, and also for r squared here, but just with n instead of n plus 1, and then simplifying that a little bit further. I'll continue to work through those and get an expression for that. Okay, so we'll need to get a common denominator here. We've got 2 and 2, and those other 2 terms we need to have 2 as well. So that's done there with a common denominator of 2. We just then need to look at well, you could expand completely and then collect any like terms, or we could take out a common factor, and we can see there's a common factor in each term here of n plus 1. So we'll take that out and then expand and simplify the remainder of it. And so having worked through those few lines, we end up with the result n plus 1 brackets and then another set of brackets 6n squared plus 6n plus 1. So that's our expression for the sum to 2n plus 1 terms. Okay, so that's the sum to 2n plus 1. Okay, first part of the question. Second part is to find its sum to 49 terms. So what we need to do then for 49 terms, we want 2n plus 1 equal to 49. So we need to find what n is. Okay, that's what we need to do. We've got an expression in n, we need to find n for 49 terms. So 2n equals 48, so that n equals 24. We can then substitute n equals 24. So that summed 49 terms will equal 24 plus 1 times 6 times 24 squared plus 6 times 24 plus 1, and multiplying that we end up with 90,025.